Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, I'll talk about multiplexer, but before that, subscribe to my channel. And at the end, if you feel this video is really useful, then share this video with your friends and press the like button. So here, multiplexer is nothing but a combinational circuit which has multiple inputs and only one output. So inputs can be 2, they can be 4, they can be 8, 16, 32 and so on. Job of multiplexer is to choose one input and to pass that input to output side. And the bigger advantage of multiplexer or use of multiplexer is we can implement any logic, we can implement any gate using multiplexer. So I'll demonstrate you how to implement, let's say, AND gate and inverter using multiplexer. But before that, let's start with the block diagram of multiplexer. Here I have taken an example of 4:1 multiplexer. So this is my 4:1 multiplexer. It has 4 inputs. I'll write names as I0, input 0, I1, I2 and I3. And I have one output Y. So we need select inputs to select particular input because we have multiple inputs. But only one input will come to the output side. So we need select inputs. So relationship between select inputs and actual inputs is 2:m is equals to n. Here n are number of inputs and m is equals to number of select lines. So here my multiplexer is 4 input multiplexer. So 2:2 is equals to 4. So my select inputs are 2. So I will take 2 select lines S0 and S1. So in 4:1 multiplexer, there are 4 inputs, 1 output and 2 select inputs. Also, one more input is present, which is enable input. So I'll write it here. Generally, we write this enable here, the lower end, but I don't have space, so I have written it here. So enable, you can assume it as a switch which is used to turn on the multiplexer and to keep it off. So sometimes enable is active low enable, sometimes it is active high. Active low is represented with E bar. And active low means when this pin will receive 0, then only my MUX will turn on. Active high is when this pin will be connected to VCC or when it will receive 1, then only my MUX will turn on. So now let's see how this works. So I have 2 select inputs, S0 is LSB, S1 is MSB and I have one output Y. Conditions for select input are 0, 0, 0, 1, 1, 0 and 1, 1. These are the 4 possible conditions. So when select inputs are 0, 0 at Y, we will get I0. So when select inputs are 0, 0, this I0 will come to Y. Then when I'll choose select input as 0, 1, then this I1 will come to output. So here I'll get I1, here I'll get I2, here I'll get I3. So in this way, this multiplexer works. So now let's see the implementation diagram. So equation for Y, I can write an equation for Y as every time enable is connected, so enable. For I0, what are the conditions of S0 and S1? They are S0 is 0, S1 is 0. So whenever value is 0, we take bar of that variable. So S1 bar, S0 bar into I0 plus. Next for I1 it is, E is of course present there, E, S1 bar, S0 because now there is no bar into I1 plus enable S1 S0 bar I2 plus for I3 enable S1 S0 into I3. So now you can see these are my AND gates, and to implement addition we use OR gate. So by using 4 AND gates and 1 OR gate, we can implement this multiplexer. So these are my 4 AND gates, and for every AND gate there are 4 inputs. So I'll show 4 inputs here. And the 4 inputs are enable, input, and S0, S1 and their complements. So we need complements of S0 and S1. So I'll write this line as S1, and by using inverter, by putting inverter here, what I'll get? I'll get here S1 bar. Similarly, S0, and by putting inverter here, I'll get S0 bar here. Then what I want is enable. Enable is connected to every AND gate. Now let's see how to connect them. So here, first I'll connect enable. Next is what? S1 bar, S0 bar, S0 bar, S1 bar, and what is then? The input is I0. Next is enable. Here dot indicates connection is here. Then S0 and S1 bar. S0. S1 bar. And here input I1 is connected. Similarly for here enable, then S1, S0 bar. S0 bar, S1, and here we'll connect I2. Here is enable, S1, S0, S0, S1 and I3. Then there is an addition of these 4 outputs. So for addition I'll use OR gate here, and this is my final output Y. And outputs to my the inputs to my OR gate are outputs of these AND gates. So in this way, we can implement our 4:1 multiplexer using AND gates and OR gate. So in exam, if question is to explain multiplexer, then you need to start with the definition. Multiplexer is a combinational circuit which has many inputs and one output. Then you need to draw this block diagram. You need to explain the relationship between select inputs and data inputs. Then truth table is very important. From this truth table, you'll get this equation. From this equation, you can draw this diagram. Now, let's see, as I told you in the beginning, that we can implement any gate, any circuit using multiplexer. Multiplexer is very, very powerful combinational circuit. Now, I will demonstrate you how to implement it. But before that, applications of multiplexer are parallel to serial converter. We have parallel inputs and one output. Then it is also used in transmitter circuits of the communication systems. It is also used in FPGAs. Now let's see how to implement inverter. Inverter means NOT gate using multiplexer. So in inverter, truth table of inverter is it has input and it has output. So if input is 0, output is 1. If input is 1, then output is 0. This is the symbol of inverter. So here you can see the possible outputs are 2. So we will take 2:1 multiplexer. It has 2:1 multiplexer because we have 2 possible outputs. My input, 2 inputs, 1 output. 2:1 is equals to 2. So number of select inputs are 1. So there is only one selection input. This is my I0, this is my I1. Now see how to implement NOT gate. For implementation of NOT gate, what I will do, I want output 1 when my input is 0. So I'll connect 1 here. I need to connect outputs in the same sequence, and I'll connect 0 here. So I0 is equals to 1, I1 is equals to 0. So when this select input becomes 0, when select input is equals to 0, then what will happen? It will select I1 and value of I1 will come here. So for 0, we will get 1. This condition is verified. Then when select input will become 1, it will select I1 and this I1 will come here and I'll get output 0. This condition is also verified. So to implement this, you need to remember this. These are select inputs and these are data inputs. Now I'll show you for AND gate. For AND gate, let's say 2 input AND gate, A, B and Y. So I'll write truth table A, B and Y. Conditions are 0, 0, 0, 1, 1, 0 and 1, 1. When both inputs are 1, then only output is 1. Otherwise output is 0. So possible conditions are 4. How many outputs we have? 4 outputs. So we will take 4:1 multiplexer. In 4:1 multiplexer, number of select inputs are 2. And these 2 inputs are, they are nothing but input A and input B. And here what I'll connect? 0, 0, 0, 1. The sequence of output which I want. So when A and B will become 0, 0, what they'll do? They'll select this first data input and this will come here. So for 0, 0, I'll get 0. Let's verify 1, 1. For 1, 1, what will happen? They'll select last input. So it is 1, so I'll get output 1. So in this way, you can implement any gate, any circuit using multiplexer. Here, for example, I have taken 4:1 multiplexer. In 8:1 multiplexer, what will happen? Only number of inputs will change and select inputs will also change. Other things will remain same. Here you need to add one more select input. Here you will get outputs up to 7. The inputs are from I0 to I7. Here you need to take 8 AND gates. And the equation will change accordingly. Here you need to add one more select input. In case of 16:1 MUX, you need to take 16 inputs, I0 to I15. Here you need to take 2 more select inputs. And number of AND gates will be 16. So in this way, you can implement any multiplexer. Thank you so much for watching. Don't forget to like and share and subscribe to my channel. Thank you.